Hello and welcome to this week's What Were They Thinking? Among the myriad news items we have for you this week, news of the claims of turbo cancer, associations between living with green spaces and slower aging, at least at a cellular level, a singular case study regarding alzheimer's, developments in embryology research, and a tiny brain with eyes. Bear attacks in Japan are at a record high. Betelgeues is about to disappear. Precise math models to describe black holes, and genetically modified organisms in children's food. The timestamps for these and other news items can be found in the description box below. Let's start with Dr. Makis's claims regarding turbo cancer and association with the COVID-19 vaccine. That this needs to be debunked is already disappointing, but it is what it is. There are various idiots out there, and particularly anti-vaxxers, who believe that the COVID-19 vaccine is causing turbo cancer. They don't identify whether this is the mRNA vaccine, the vaccine that's made by inactivating the COVID-19 cells, or in this case virions, or if it is the DNA-based vaccines. They just say that they cause turbo cancer. The turbo cancer itself has no set definition against regular cancer, and there's been no way of differentiating it on that basis. So they've been going around claiming that any cancer is turbo cancer if given the opportunity. The Science-Based Medicine blog provides a very good summary of Makis's in particular actions in regards to this and the bullshit they are spreading regarding it. One thing this blog post does better than the anti-vaxxers do is actually summarize their position and rationale as to how they think the vaccines might be causing the turbo cancer. The first being the idea of liposomal nanoparticles get into the body, that the mRNA vaccines interfere with the immune system surveillance of cells and thereby prevent the removal of cancer, that DNA might be integrating into tumor suppressor genes, or that DNA plasmids might be getting into the microbiome and causing issues with that. And none of these are actually true or even remotely rational. First of all, the liposomal nanoparticles aren't a major problem. There are a whole bunch of different things in the human body that use liposomes. They're not unique, they're not special, they don't cause it. Modification of mRNA would not suppress the innate immune system. The innate immune system, frankly, only gets suppressed if your bone marrow is harmed. Of course, that also involves damaging the skin, which is one of the parts of the immune system, and mucous membranes, another part of the immune system, and so on. In this case, they seem to just be referring to the innate immune system in an attempt to make their claims sound more realistic. And then we have the DNA fragment integrating into the tumor suppressor genes. No. In order to integrate something into a gene, you need to have the appropriate insertion mechanisms, something not only absent from these cells under normal circumstances, but even if we're talking about the concept of when you're using a vaccine with mRNA or DNA, it's still not there. And then finally the DNA plasmids for the microbiome, which again, the same issue. So none of these mechanisms are actually viable or realistic. The blog post goes into a great deal more detail on other factors and parts of this that are both better and worse. Good news is that it goes through some of the strengths of the people who have been involved in this. Bad news is they've effectively been so naive as to believe what they've seen with very little question. Shifting to news that's, similarly novel, but also arguably just as questionable, regarding skin piercings and the microbiome that is present on our skin. Make no question of it, there is native flora present on everybody's skin, regardless of how thoroughly you may think you've washed yourself. It is there for a series of very good reasons, one of the most fundamental of which is simply, if there's already a population of bacteria on your skin, new bacteria that are often pathogenic or at least very undesirable given what they'll do, cannot make their own colonies, thereby preventing random and unintended infections. This of course does lead to things like pimples occurring when said bacteria get within a pore, but most of the time they exist with relatively no harm whatsoever. This leads to the research of a kind where they collected skin swabs from 28 volunteers who got skin piercings. So we are talking about a very, very small study here, which is why it should be taken as preliminary and arguably somewhat questionable. Well, honestly, a lot questionable, but nonetheless. What they found is that with the samples taken at the time of piercing and 2 weeks later, there was a shift in the microbiome, which, to be frank, is none too surprising. To start with, they would have had to sterilize the site where they were going to do the piercing, which would have effectively decimated the population, if not completely wiped it out. Yeah. So seeing a difference after the fact is like saying we've seen something at all, which should be no surprise, remembering that there is nearly always a native population of microbes on your skin, including your earlobe. We wonder whether or not this would qualify for an Ig Nobel Prize. Shifting to slightly more useful results and research, we have an association between living in green areas and slower aging, at least at a cellular level, which isn't actually new research. There have been consistent and long-term findings that those who live, or at least spend more time in green areas, such as parks, out on hikes, and otherwise exposed to the natural environment, tend to be happier, healthier, and somewhat live longer. This is where the research here is kind of useful, but also really only almost drilling down and becoming narrowly specific on what happens in the cellular level, rather than the whole organism level. The findings aren't necessarily as useful, although they are fairly large in terms of sample size. It's about 7,800 people. In terms of those individuals, they looked at the areas they lived in, and in this case, those areas with parks, gardens, greater vegetation like trees, and so on. Those individuals who had more of the green space around them had longer telomeres. Telomeres being the caps on the end of DNA that keep it from unraveling. What's important with this research, rather than just telling us about the telomeres, is that these results appear to be true regardless of other factors, such as race, economic status, alcohol consumption, or tobacco use. These are particularly important as they tend to be factors that contribute or are associated with a reduction in life extension. For example, a low socioeconomic status is, well, to be blunt about it, poor individuals or those who are uneducated. They tend to have a worse diet, worse environment, and so on. Race, depending on how you view it, can also be contributing to this because it's associated with other issues, such as cardiovascular disease. And then there's alcohol consumption and tobacco consumption, which are also associated with issues to do with longevity. The amount of impact this has is arguably not that much, and is really only the difference between male and female life expectancy for the most part, at somewhere between 2 and 2.5 years. Next we have a far more questionable piece of research, and it's a link between picking your nose and developing dementia? Yeah, it's dementia, Alzheimer's, and other similar neurological conditions. The research is theoretically possible, but very, very novel. And we're using novel in this context in the same way you might say that's very interesting to a child. It's novel for a number of reasons, and the first of which is simply, we really want to know how they've been picking the nose of the mice involved. Is there a really tiny finger on a stick? Other than that, it is a mouse-based model, and, statistically, it's incredibly unlikely to translate to humans. As such, The findings could be interesting for the longevity of your mice, but not necessarily for a human. The mechanism that is being proposed is reasonably straightforward. There is a particular kind of bacteria called Chlamydia pneumoniae, which is associated with the development of neurological diseases like Alzheimer's and dementia. It's thought that if you pick your nose, there is a means by which the bacteria could travel up the olfactory nerve to the brain and thereby access the brain system and stimulate the development of these diseases. To be clear, a plausible mechanism is not the same as the actual mechanism and, again, a rodent model. In related news, we have a woman who appeared to be at incredibly high risk of developing something like Alzheimer's disease, but never did. The woman effectively won the lottery. Her family had a very long and very distinct history of developing neurological diseases, some of whom were experiencing it from their 40s onwards. This lady appears to have been protected because she had 2 copies of the same gene. It's the ApoE3 gene. This gene, and the particular variant she had, appears to have been what allowed her to avoid the issues in question. The researchers have then looked at testing this in a mouse model by giving the mice in question the same mutated gene and seeing if they survived without neurological effects. And, well, yes, we wouldn't be talking about this if they didn't. What's important about this case study is that it shows a possible mechanism to break the early and late stages of something like Alzheimer's disease and prevent progression, or at least as significant progression. What they found is that she still had various issues, particularly around the development of amyloid plaques, but the tau proteins were not present. This meant that the cognitive impact was present, but it came on very late and it was incredibly mild, especially by comparison to those who have the full progression of both amyloid and tau proteins. The reason for this appears to be that, much like the Imperium of Man, this new genetic modification means that the immune system can very quickly and very easily clear up the tau, specifically the tau protein. And this is down to the way the microglia aren't being handicapped as they would be in other circumstances without this particular variant. Next we have a development with regards to weight loss and the use of drugs to, well, try and fight off obesity, which does seem like a relatively stupid idea. The use of a drug, and particularly things like, say, Ozempic and similar, has been touted as a means of, well, making people lose weight, which in theory is great, except for exactly what they found here. Once you stop taking the drug, you put the weight back on. Yeah. The idea behind weight loss is not just to be able to take a drug and fix it for now, but to fix in the long term. That means when you lose the weight while using it, you should be learning how to stop your food consumption so that your calories remain relatively equal with what you're expending each day. If you don't figure out how to do that, you wind up in this situation where even if you do take the medication, you don't get any benefit, in the long term anyway. The results are based on following 670 adults for 36 weeks. At this time, they lost about a fifth or 20% of their body weight, which is good. For most individuals who are overweight, this should bring them back in line with being within the normal weight range. For those who are obese, well, it's not perfect, but it's a lot better than being obese. The individuals involved were then split into 2 groups, one who remained on the drug in question and the other half being given a placebo. At 88 weeks, the individuals were weighed again. The researchers unsurprisingly found that those on the placebo had been regaining the weight they lost at about 10% of the body weight that they had been able to remove using medication. Those who remained on it lost about 25% of their body weight by the end of the 88 weeks. so a further roughly 5% loss in body weight. The importance of these results are fairly clear-cut. First of all, the participants were encouraged to consume fewer calories each day than they would otherwise be using, and that they should partake in 115 minutes or about 2.5 hours of exercise each week. Despite this, the placebo group continued to gain weight. That raises issues to do with adherence amongst other factors, but it also indicates that there is a certain need for some people to continue the medication to reduce their body weight. The importance of this cannot be understated. Things like being obese or even overweight drastically increase the risk of events related to cardiovascular disease, heart attack, stroke, and so on. Then there are other issues like a significantly increased risk of diabetes, kidney problems, liver problems, and more. All of these related to being overweight or obese. This is one reason why the medication is particularly important in terms of almost being a prophylaxis, thereby avoiding the issues. But of course, constant need for medication, and particularly its secondary effects on the market, thereby depriving those who are diabetic of the necessary insulin antagonists, is a big problem. There is also the issue that we don't know much, if anything, about the long-term effects of taking this medication regularly. Notably that medication like this does have an effect on the stomach and the movement of the muscles within it. It slows down their activity, thereby preventing gastric emptying. This could, in theory, have an effect, particularly on the activity of the stomach. The other concern, mostly if you live in America, is the sheer cost of some of the medication, at up to $1,100 every month, which, yeah, that's a lot of money, and most people, and especially those who are at greatest risk of being obese and overweight, can't actually afford it. Shifting to other news, let's say, about developments, but specifically development of a model for, well, not only the brain, but for eyes as well. Although in this case a very crude and preliminary model. The idea here is to create a miniature brain using stem cells, which is all well and good. The second thing that occurred though is the development of eyes on said brain. Now this is intended to be an organoid, not an entirely developed embryo model, although it is building on the same basic concepts of embryology. In this case they're just focusing on a very, let's say, a narrow subset of the part of the embryo that they want to look at, which does avoid a lot of ethical and moral problems. Because they're able to grow it the way they are, they can use stem cells and effectively culture a petri dish with this within it, which is a lot better than trying to grow a 3D model. These findings are not just limited in usability to weird findings. Rather, they're incredibly important in terms of embryological development and what is necessary going from multiple cells to a blastocyst and then gastrulation, followed by what is effectively the early stages of a fetus. The knowledge of how, where, what, and why are needed for eyes will help in issues like, for example, blindness and similar, especially in newborns, where you may theoretically be able to, for all intents and purposes, avoid issues with newborns who are born with eye problems. These findings contribute considerably to understanding how these cells organize themselves, and in doing so, how they get the right cells for the eye to be where it is. Previous research has been able to achieve the same end result, that is optic cups, but they had to induce that to happen. This research relies entirely on the cell culture organizing itself using its own cell signals and so on to induce this change. Next we have designer magic mushrooms. Well, sort of anyway. The point of this is that we could theoretically be genetically modifying magic mushrooms to address particular problems. For example, addressing treatment-resistant depression, although that research is relatively preliminary. The work took 124 different isolates from a variety of cultivars of magic mushrooms and tried to figure out which of them was useful and which of them wasn't. They then sequenced the genome of 38 of these to then further understand what could or could not be useful. The 38 isolates were compared to 86 commercial cultivars of magic mushrooms that had already been sequenced, giving us the total 124. This is useful as we now have a range of different possible features that could be swapped in and out to better, let's say, improve the magic mushroom. The researchers themselves note that the varieties of magic mushroom that had been domesticated had very little, if any, diversity in their genome, and just about all of that was focused on sexual reproduction. In wild or naturalized magic mushrooms, that wasn't the case, and as such, it indicates that there could be scope for improvement based on naturally occurring genes or the wild magic mushrooms that are out there. In other news related to nature, we have bear attacks in Japan reaching a record high. Why people think it's a great idea to go up to a wild animal, or in this case attempt to approach a wild animal, and pat it or otherwise interact is kind of amazing. It is, by its nature, a wild animal, not domesticated. It's not a pet. Thereby trying to pat it or feed it or anything else is just bad and dumb. And yet, this is what people do. To some extent, at least in Japan, the increase is not just driven by people being stupid. A part of it is being driven by an aging population and changes in environmental conditions, leading bears to spend a greater deal of their time in closer proximity to humans, or at least human settlements. In the last 11 months of 2023, there have been 212 attacks by bears. This, of course, does not include those who are able to avoid being attacked by escaping, or otherwise didn't report the event itself, which is a concern. Historically, and under normal conditions, most of the bears and bear attacks are in the far north of Japan, where the environment is less than hospitable to humans, and the bears find themselves with a lot of wild environment to live in and not be bothered. But the belief is that because of the environmental changes, their naturally occurring food sources are being disrupted, and so bears are moving in to urban places, whether that is smaller towns or villages, to get food themselves, such as trash. And this leads to the current problem. The current solution to this is, rather than culling the bear population or otherwise ultimately killing them, the governments in the area are offering the option of trapping the bears and a bounty for that. Now, to be clear, we're talking about trapping them alive and not anything that would permanently kill them or otherwise harm them in the long term. Other areas are basically chasing the bears away by patrolling with dogs that mark the territory and discourage the bears from entering. Shifting to physics news now, we have a possible way to unite gravity and quantum mechanics, although this is, again, a theory, which, understand in scientific terms, a theory is very different to how it's normally used in common parlance. In this instance, it is a way in which you could describe an underlying phenomena that is effectively true in the world, and you just have to test it by taking whatever thing you want to look at and applying it to this theory. The problem is both gravity and quantum mechanics don't really mesh that way. There's been no way to be able to get a theory like, for example, evolution, that can take two disparate concepts and get them to work together. The reason for this is that gravity is based in what you could effectively summarize as classical physics, whereas quantum mechanics is, well, relatively new. This then leads quantum mechanics to argue that we don't actually live in a classical physics universe, which creates an issue when things like gravity are based on just that. To put it a different way, quantum mechanics takes everything in the universe and says that it is based on incredibly tiny events that have a probability of occurring, whereas a classical model of the universe in physics looks at things at a macro scale, that is, all of the massive things that we see. Well, massive in terms of anything bigger than a tiny grain of sand, and even that might still count. Up to now, there have been what could effectively summarize as two different camps within physics, and these two camps are what are trying to unify the concept of quantum physics and general relativity as an example of classical physics. The camps being loop quantum gravity and string theory. Neither of them have been dominant, and neither of them have been entirely successful in being able to explain how to make the two ideas work together very well. This is where a third camp popping up out of largely nowhere is creating some waves. It's the post-quantum theory camp. In order for this new contender to be able to make its own camp within physics and establish itself as a viable explanation, they need to find answers to one of two things, if not ideally both, and that is how to reconcile the quantum theory and things like general relativity. And the only way to do this is either to, first of all, they can try and quantize gravity, which that's going to be hard to do. And the only way to do it is to, effectively measure a set mass multiple times and see whether or not it will vary within our ability to measure. And this would show whether or not there are fluctuations within it. These fluctuations would effectively be measuring changes in space-time. The other way is to see whether or not we can find an atomic thing and a subatomic thing in a state where it occupies two different places in space simultaneously. This one is even harder again, given the range of issues with, predicting and then finding something that will occupy two different places at the same time, but also the scale at which they're going to be measuring things. More than anything else, though, it's how long it will take for them to be able to evidence what their theory shows. It'll be at least 20 years. Yeah, we're not going to have results for you anytime soon. Next we have news on Betelgeuse, one of the most visible stars in the night sky. Over the last few years it's been behaving oddly, and honestly nobody was entirely quite sure what was going on at first. But now we know what it is. It's down to a passing asteroid. This asteroid will block all of Betelgeuse's light from Earth for about 5 seconds, so it's effectively a solar eclipse in miniature, largely due to the distance between Earth and Betelgeuse. The eclipse itself occurred on December 12th, and that's when it disappeared from view altogether. But remembering, it only disappeared for about 5 seconds. What's special about this event is not that it's occurring, but the size of the asteroid is key here. It is just large enough to block the sun while leaving a ring of fire around it. What's special about this is not so much the result that we're able to appreciate ourselves, but implications for those who are in astrology and physics. It's what they can get in terms of data from this event. They can see a lot about the gases that are being burned in the star based on what they view in the corona. In other astrological news, we have, good news, and that is Hubble Space Telescope is back in action. It entered itself into a safe mode recently, on November 19th to be specific, and fortunately, the safe mode ultimately got resolved, allowing us to have it working once more. The reason for its shutdown, albeit temporarily, was due to a gyro failure. That is one of the parts in it that allows it to be aligned successfully. Unfortunately, only a few days later, it once again went into safe mode, and it didn't resume operations until the 8th of December. And the problem there was much the same issue. It was all down to the gyros in the telescope, which allow it to not only be aimed properly, but also provide guidance in what's happening. Understand that Hubble Space Telescope has never been expected to survive as long as it has. It has long since gone beyond its expected lifespan. When it was first deployed in 1990, it had 6 gyros that were present. These failed, and they were replaced with new ones in 2009. Now, half of those newly designed and newly installed gyros have also broken, leaving only 3 behind. Sadly, NASA has no intention to allow Hubble to be refurbished and rebuilt again, so once these 3 fail, it's gone. We won't have a Hubble telescope that works anymore. Well, it'll work, we just can't use it very well. In a slight throwback to the earlier issue of physics, but also astrological news, we have a math description of how black holes reflect our universe, and this is one of those weird things to say, as technically a black hole doesn't reflect the universe as everything gets sucked into it. But nonetheless, the issue with this model is not so much reflecting light, as how it shifts the light around the black hole. When you shine light, or more accurately when light is shone near or around a black hole, it gets pulled in a certain way, and this is called warping. When the warping occurs, it has a weird effect on the universe. Let's put it that way for now. The model fundamentally comes down to looking at the angle of observation and the rate of the black hole's spin. This was a solution worked out by a physics student in July of 2021. What's useful here is that it allows us to understand why the images we see repeat themselves in a particular way. Otherwise, what we'd be observing just doesn't make sense. It's really cool to see, but it doesn't make sense. What their model is able to explain is that once light gets to within the grasp of the gravity of a black hole, its speed, which is theoretically the fastest achievable velocity in the universe, is unable to escape the black hole, but it's not drawn straight into the black hole. Instead, it spins around it in a particular way. As such, we see the light until it eventually hits the black hole's event horizon. Until then, it continues to curve in space, particularly space-time, because of how the black hole causes everything to go in a spiral. This is true of the vast majority of light that's going to enter a black hole, but there is some that can escape out, arguably through pure luck given the lack of a better explanation, but nonetheless it escapes. This does lead to one bizarre phenomena, and that is we can get light from the same object in space coming out of the black hole at the same time, leading to the same image being reflected multiple times. Of course, this is just a model, and therein lies the crux of the issue. In order to be able to prove what we're seeing, we'd have to get images and we'd have to process them. And previous attempts that were successful required ridiculous amounts of resources and time, meaning that we're not going to get a proof of this model just yet. The final item we have for you this week is more an example of bad research and writing. And disappointingly, it comes from the conversation, which is often a fairly good example of a attempt at communicating science. The results, let's call them, are all about glyphosate and the fact that it's present in women who live near farms. Now, the issue here is one of, well, several-fold actually, but the first is simply the dose that they're exposed to, the amount that they're actually detecting, and third and finally, if, and this is a massive if, it's actually relevant numbers. Yeah. This is the concern right now, that what the conversation has been sharing is, frankly, not really at all helpful. All it does is, well, act as a fear-mongering source of information. Those who are, say, organic might argue that, oh, well, no, this is better for you, but no, all they've done is substitute glyphosate for something else, and often particularly nasty herbicides instead. So we need to talk about what was actually found and why the research as it's being touted here is, well, kind of bullshit. First of all, they measured those women over 10 months who live within 500 meters or about a third of a mile of farming fields. So this is our first issue with it, the time frame involved. Most farming is done over the year, and over the year they use glyphosate at different times, and certainly for different reasons, meaning that we don't know exactly whether or not exposure was based on them only having sprayed the day before and then done a urine test, or if they had done it 6 months before and they hadn't done it since. This is a big problem. The next issue is, well, it was pregnant women over those 10 months. So they're already trying to associate this with women who are pregnant and thereby effectively stimulate an emotional response, not a factual response. The researchers do claim that they only found results when the fields were sprayed, with a dose response associated with proximity to fields. That is, those who were closer had more in their urine. But if they're arguing that the agricultural spray was the source of exposure, they ought to have had some sort of control group to be able to make that claim. Further, they try and use the IARC report. The IARC report that was statistically analysed by the guy who went on to be paid for by the lawyers trying to sue companies like Monsanto, who, before they finished the IARC report, was receiving money from those same lawyers to prepare for that lawsuit. It's a huge issue, and the report itself has been heavily criticised by a wide number of academics who know about this area and about the failure to include a raft of studies that were both better and, importantly, ran contrary to the claims of IARC. And then, of course, we have the fact that they only looked at 40 women. This is a tiny number. A very tiny number for what they're trying to claim. They also somehow got nearly 1,400 urine samples from these 40 women. At just one a week, this is already a problem. One urine sample a week from 40 women, and over 10 months, isn't necessarily all that helpful. It largely comes down to the fact that, well, 40 women isn't a great deal, and if it's a weekly sample, we don't know whether or not you're going to get reliable results. The best case they could make is that with 40 pregnant women, they could assume normality of their results, but assuming makes an ass of you and me, to use the rather, well, painful expression. The researchers also claim to have provided the individuals with a week of organic produce and a week of conventional produce. Organic produce has already been repeatedly tested and found to be contaminated with glyphosate, so that tells us already that their design is shit. Second to that, a week is not enough if you want to ensure that the individuals in question have cleared out anything and everything from their system. Yeah, it's just not going to work. This brings us back to what we said at the very start of this section, and that is the dose. What they found aren't biologically important levels of glyphosate in either group. And this is whether we're talking about when they're using conventionally grown food or organically grown food, or at any other time of the experiment. In fact, arguably, throwing that organic and conventional growing thing in there is kind of a bullshit way to throw up any random result and claim anything, since you've disrupted the normal progress of things. They'd have been better off running their experiment and then proceeding later on to do that. So they had two distinct sets of data. One from when they're talking purely about glyphosate exposure, and one from when they conducted an intervention using organic and conventionally grown food to see if there was a difference. But no, they didn't do that. They chose to instead to screw up both sets of data by conducting an experiment in the middle of another experiment. Well, in this case, a data collection. This is why the conversation is going to shit. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.